Hello everyone. So this is the answer section for the CKA practice exam 2. So let's get started. If you click on the exam portal, it launches this UI, and as you can see, we've got 8 questions, overall percentage of 100. About 3 to 4 of these questions are of easy difficulty, and the remaining ones are about intermediate to difficult. So according to the difficulty of the questions are graded. Some of them have a weightage of 10, some of them have 14, so on and so forth. So let's have a quick look at the test environment. So this one is a 2-node cluster, and there is a master server called master and node 01, which is a worker node. Okay, so let's go to the first question. The first question is take a backup of the etcd cluster and save it to /temp etcdbackup.db. That's easy enough. For this, we can make use of the Kubernetes documentation. So here's the documentation, and to take a snapshot or a DB backup, the command to be run is etcdctl snapshot save. And here's a nice little example. The one thing to note in our scenario is that we have to parse the certificates. So there is a handy little trick to do that. First, let's check the version of the etcdctl that's installed. Yeah, so the version is 3, which is exactly what we want. Now let's go to the etc Kubernetes manifest folder, which is where the configuration details of the static pods are stored. And if you check the etcdctl.yaml file, you can see all the parameters that need to go into our command. So let's copy it from here. So I just commented it out for making it easy, and that's the entire command string. And now to check that this command works, let's just do a member list. So as you can see, it works. So now we can take a snapshot backup. The command is snapshot save, and this is described here in the documentation as well. And let's go back to the question and copy the directory. So there you go, that's done. And to verify that it's working properly, let's do a snapshot status and write to a table. So there you go, that's question number 1 out of the way. And let's move on to the question number 2. So the question number 2 is create a pod called elephant with image Redis with CPU request set to 1 and memory request as 200 MIB. Okay, and that also has a weight of 10. That's easy enough. So let's get started. So for this, what I would do is create a template file using kubectl run. Let's double check. Let's say pod name is elephant and image is Redis. So I'll use the try run feature so that the pod is not created and output the contents to a YAML file and redirect it to a file. Let's call the file the same name as that of the pod. And now we can edit this file. So as you can see, there is also already a resource section which is empty, so we can add the request section here. Let's make sure it's correct. Name is elephant, and yeah, so 200 MI, and that should be it. So we'll create the pod using kubectl create -f elephant.yaml. And to make sure that it's created properly, we can run a kubectl describe pod elephant. And as you can see, the request is CPU is equal to 1 and memory is equal to 200 MI, which is exactly what is asked for in the question. And the name of the pod is elephant. So we can go to the next one. Okay, so the next question is to create a new pod called super user pod with image busybox 1.28. So you have to use the specific version. Allow the pod to be able to set system time, and the container should sleep for 4800 seconds. So this is a security context related question. So let's go back to the Kubernetes documentation. All right, so here is the relevant documentation that can be found under task, configure pod, container, and security context. And as you can see here, this is configured within the pod deployment template. And there is this field called security context, and you just have to add capabilities with an add feature, and in this case we just have to use system time. So let's go back to our terminal here, and since we already have a pod definition file for the previous exercise, we can copy that, and let's name it superuserpod.yaml. Let's make changes. We don't need labels here, so I'm going to delete it here. And then let's rename the pod name to superuserpod busybox 128. Yep. Name can be same as the pod. We don't need the resources section here, so I'm going to delete it. In fact, we don't need any of the other ones, so I'll remove all of the lines. Now here I will write down security context. Capabilities, and we have to add sys time. Let's go back to the documentation, make sure that's correct. So security context with a capital C, capabilities, add, and we don't need a net admin here, so that should be that. And the other thing that we also wanted to add was the command field. Because this is a busybox image, it will exit if it does not have a startup command. So let's, this one was to sleep for 4800 seconds. Let's just make sure everything is right. So the name is super-user-pod, busybox 128, 4800 seconds, and sys time. Busybox, super user pod, name of the container is the same. There's a command for sleep 4800 and capabilities add sys time. Okay, let's create this pod. That's created. We can run kubectl describe pod super user pod just to make sure that it's running. It is running sleep 4800. The name is exactly what we need. Okay, so that's this question done. Let's move on to the next question. Okay, so the next question is a pod definition file is created at /root use pb.yaml. make use of this manifest file and mount the persistent volume called pv-1. Ensure the pod is running and the PV is bound. So PV has already been created and there is a pod manifest file or a framework of that which is created in this directory. So you have to create a persistent volume claim, and here are the specifications for that. So there's a mount path and the name of the persistent volume. And then you have to make sure that the pod is running and that it's using this persistent volume claim. Okay, so let's go back to our terminal here. The first thing that we have to check is if there is indeed a persistent volume or a PV which is created. So there you go. So there is a PV-1 which has a capacity of 10 MI with read-write once access mode, and it's available. So there's no persistent volume claim that has been created. So to do that, let's go back to the Kubernetes documentation. Okay, so here is the documentation. And as you can see, we just have to create a persistent volume claim since we already have a persistent volume created for us. So here is an example that we can reference. The API version is v1, kind is persistent volume claim, and we just have to fill in the details with the correct specification provided in the question. Okay, so let's create a pvc.yaml, and we know that the API version is equal to v1. That's me here. Kind is equal to persistent volume claim, metadata, name of the persistent volume is my PVC, and the specification, the first one is the access modes, and we just have one which is read write once. And let's go back to the documentation. Next one that we have to fill in is the resources section, so we can copy it from here. And let's make sure it matches the persistent volume, which is 10 MI. Let's quickly verify my PVC and access modes. Yeah, read write once. Let's create this. So we have a persistent volume claim that's created. Let's check the status of the persistent volume itself. And now, as you can see, it's in a bound status and it's being used by the claim that we just created. So the next task is for us to make use of the Yes, so this has already been created for us. So we'll just make sure that we enter the details for the persistent volume claim here and then mount it as a volume. So if you go back to the documentation, you can see a section called as claims as volumes. This has got an example of what we can do to mount the persistent volume claim as a volume. So the only thing that we have to do here is copy this line here. Now we don't need the resources, DNS policy, or any of these. So we can add the volume mount section here and make sure that this mount path is exactly what is mentioned in the question. So this one should be /data, as you can see here, and this name can be anything. That's basically the name of the volume that is created, and that we will define in a minute. Just make sure the syntax is correct. And volumes, can copy these as well and paste it underneath. And since we have already named my PD, I'll just leave it as it is and make sure it's all aligned properly. The claim name should be my PVC. That looks right. So let's create the pod. There you go. It has been created. Let's quickly check the status. It's running. And if you see under the volume section, there's the volume name, and that is making use of this persistent volume claim, and the claim name is my PVC. And if you check the status of the PV, it should be in a bounce state still. So that's this question that's completed. Okay, let's move on to the next question. Okay, so the next question is create a new deployment called nginx deploy with image nginx 1.16 and one replica. Record the version. Next, upgrade the deployment to version 1.17 using rolling update. Make sure that the version upgraded is recorded in the resource annotation. Okay, so first we have to begin with a specific version with just one replica and make sure that's recorded and upgrade it to 1.17. Also make sure that it's recorded. Okay, so let's go back to the terminal. Okay, the screen here. So kubectl run, name of the deployment should be nginx deploy. Image, let's copy it from here. That is nginx 1.16. And replica is 1, which is the default anyway, so you can choose not to enter that. And we have to record the version. So if you run kubectl get deployments, it's still creating, and there you go. Well, there's 1 out of 1 which is ready. And to check the revision and the recorded annotation that we have passed earlier, or did we do that? Yeah, there you go. So there is a -n record. So in order to check this, we can simply run kubectl rollout history deployment and the name of the deployment, which is nginx deploy. As you can see here, the first revision has the change cause, which is recorded here, and that's the exact command that we ran. Okay, so let's go back to the question. The next step is to upgrade the deployment to version 1.17 using rolling update and make sure that's recorded as well. Okay, so we can make use of kubectl set image deployment, name of the deployment here. Copy from here, and then name of the container, which is also nginx deploy, and the version of the container that it has to go to, which is nginx 1.17, and we'll record this as well. That command has been completed successfully. Let's check the status of the deployment. Let's quickly check the image version. So I can see that that has changed to nginx 1.17. kubectl get pod nginx deploy. So that has been recreated 40 seconds ago. We can run a describe just to make sure that the pod has been updated. And that has been updated as well. Okay, so now let's go back to the rollout history command. And as you can see, the second revision is the change that we made, which is set image from 1.16 to 1.17. And I think that should be it. Deployment with nginx deploy. The initial version is nginx 1.16. Upgrade the version to 1.17 and record changes. So yes, this is complete. You can move on to the next question. Okay, for this question, we have to create a new user called John, grant him access to the cluster. John should have permission to create, list, get, update, and delete pods in the development namespace. The private key exists in location /root john.key and csr/root john.csr. Okay, so let's go back to our terminal here and make sure that the two files have been created. Yes, as you can see, there is a john.key, and using that key, john.csr has already been created. So for this, we'll make use of the Kubernetes documentation to create a certificate signing request. So we are here at the documentation, and this can be found under TLS and managing TLS in a cluster. And here is a sample CSR file. So the API version is certificates.kh.io. We can also check this from the command line too. So if you run kubectl API versions and grep for certificate, you can see that it returns the API version, which should be the same as the one that you can see in the documentation. So yeah, let's create this CSR. So I'm going to call this file as a vi john.yaml API version. I'm just going to copy that line from the documentation. And the name should be in the question. So the CSR name should be John-developer. Status should be approved. And we have to create the required roles for him to be able to access and do the actions on pods in the development namespace. So John-developer is the name. I'll just copy it from here. And let's check the spec section. There is a request, which is the CSR itself. And then, yeah, okay. And the usages, I'll just copy from here. That's digital signature, key and cipherment, and server auth. So now let's go back to our file, which has been auto-created for us, called john.csr. And we'll use base64 to encode it. And then using translate tr, delimited by a new line to remove the new line. That should be it. So we'll copy the whole thing until here. Let's go back to the file and paste it here. That should be it. So clear the screen. kubectl create nf john.yaml. There you go. The CSR has been created. We can verify this by running kubectl get CSR. I can see that's in a pending state. So we have to approve it. So kubectl certificate approve John-developer. That has been approved. Let's run that again. And as you can see, it's in an approved state. So that's one part of the question that's completed. Let's go back to the documentation. Okay, so the second task is for us to create a role name called developer. The namespace is development resources pods, and here are the verbs associated with that role. So let's create it using the imperative way. CTL create role, and the name of the role I'll just copy from here. It's developer hyphen resource is equal to pods hyphen verb. I'm just going to copy it from the question. Make correction to the syntax. So it should all be comma separated. That looks all right, and the namespace is development. Pods, the pod list, and the namespace. That looks all right. So that has been created. We can run a kubectl describe role for developer. The development namespace. That looks all right. So now let's go to the next section of the question. So John should have the appropriate access. So we'll have to create a cluster role binding, not a cluster, sorry, a role binding. Does it have a name that's mentioned here? No, so we can create any name. So kubectl create role binding, and I'm just going to call that as a developer role binding, and the role name is developer, which we created in the previous task. The user should be John, and namespace should be development. That has been created. Let's do a quick describe role binding. As you can see, user John, and it is in the development namespace, and the binding has been created. Okay, so that looks like that has completed the question. Just to verify, let's run a couple of quick commands to test if John has access. So can use kubectl auth can I. Let's take one of the verbs from the question. So update pods. Now if I just run this as it is, it should say yes, because this is being run as the Kubernetes admin user. And so we'll have to key in -- as and John. Now this should say no because you're not specified the namespace. So let's try that. So yeah, so John has access to update pods. Let's try a couple of other verbs which we added. So list, that works. Let's try delete. Yes, nothing in here. So let's try watch pods, which we have not added. So this should come back with no. So there you go. So all the required permissions has been set. And then we can move on to the next question. Okay, so the next question is create an Nginx pod called Nginx Resolver using image Nginx, expose it internally with a service called Nginx Resolver service. Test that you're able to look up the service and pod names from within the cluster. Record the results in /root nginx.svc and /root nginx.pod. So in this case, we have to create a pod, expose it as a service, and run an NS lookup against both the service as well as the pod name, the pod IP, and then record the results in these two specific files. Okay, so let's go back to the terminal. To begin with, we'll create the pod. Just copy the name from here. Images Nginx. Let's copy the name of the service. and you have to use the port, which for Nginx would be port 80. The target port would also remain as port 80, and you can use -- type to describe the cluster, the service type. This is by default cluster IP, so this can be omitted if needed, but the remaining things are needed, especially the -FN port. So kubectl expose pod nginx resolver and create the service name by nginx resolver -service. That should be it. Yeah, that's a syntax error, so you have to use -FN name. There you go. kubectl describe svc nginx resolver service. As you can see, that's resolving to a cluster IP, and it has got one endpoint, so this should be the IP address of the pod. Yes, so if you run -o void against the pod name, you can see that the pod name is 10.32.0.5. So both the pod and the service has been created. So this was created by mistake. Let me delete it. Right, so that should be good enough for the first part of this question. Okay, so the second part of this question is that we have to test NSLOOKUP against the service and the pod name. So we'll run a busybox pod to test that. Okay, so back to the terminal, we will create a busybox pod to test the NSLOOKUP to the service and the pod name. Let's name the pod as test NSLOOKUP. Image should be busybox. But keep in mind that certain versions of busybox does not run the DNS utils correctly. What that means is that it is not able to do an NS lookup correctly, so you'll have to use a specific image such as busybox 128. Then we'll run it in a -rm and a detached mode, followed by the NS lookup command. So first we will test it against the service name. Let's see if it works. So in this case, it was able to resolve it. So let's run that command again and divert the output to the file. Let's check the contents. So yes, you can see that the address has been recorded. You can ignore any other things that it has recorded as well. So the next one, we have to try to resolve the pod itself, and for that we'll run the same command, but we'll have to get the IP address of the pod itself. So you can see that the IP address is 10.32.0.5. So in this case, we have to replace the dots or the full stop with hyphens. So 10-32-0-5 dot the namespace default dot pod, and this should be saved to nginx dot pod. Okay, so that's done. Let's see if the command was successful. And as you can see, it has been able to resolve it, and that's the name that it tries to resolve. So always remember to replace the dots with hyphen, and you have to give the namespace and pod. And this can further be extended to pod dot cluster dot local. So that's all the tasks for this question. So we can mark this as complete and go to the final question. Okay, so let's go to the final question of this exam. So for this one, create a static pod on node 01 called nginx-critical with image nginx. Create this pod on node 01 and make sure that it is restarted automatically in case of a failure. And here it's specifying the path to be used for the static pod. So this essentially means that we have to create a static pod in node 01, and the name should be nginx-critical and the image is just nginx. So Cubelet should be configured for static pods or nginx-critical. That's the name. Okay. So let's go back to the terminal. So let's run kubectl get nodes. As you can see, node 01, that's in a ready state. So let's SSH to that node. So passwordless SSH is enabled by default. So you can go to node 01 from the master. And before we do anything else, let's check the status of the Cubelet service. So that's running. You can see the parameters here. And the configuration file is /var lib kubelet config.yaml. Okay. And here so the static pod path in this case is already there. If it's not there, you have to add it here and make sure that Cubelet is restarted. So since it's already here, we don't have to do anything else. So this is already part of the Cubelet configuration. So let's see if that folder exists. In this case, we don't have that directory. So let's create one. So Cubelet configured for static pods. So we have created this directory. And now we have to place a pod definition file within that directory. So let me go back to the master node and run kubectl run -generator. So I'm just going to copy the contents from master node Now go back to node 01, which is the worker node, and go to the directory that we just created, and the name should be nginx-critical. Here's the contents here. Make sure the syntax is correct. That looks all right. So I don't have to create it because this path is already configured in the kubelet as a static pod path. So it should take care of creating this automatically. We can check with Docker. You can see that there is one that is running on this node already. That's up. So let's go back to the master node so that we can run kubectl to check the status. So as you can see here, there is one that is created 39 seconds ago. It's called nginx-critical, and this is the node name where the static pod is created. So if this was master, that would it would be called as -master, such as most of the control plane components. But in this case, since it's on the worker node 01, it has got taken the name of -node01. So that's it. Let's just verify that everything is correctly set up. So create a static pod on node 01. That's the name. We just have to specify the image, and then yeah, we have already created this path in node 01, which is made used by Cubelet service, and then pod nginx-critical-node 01 is up and running, which it is. So that's the end of this exam. Let's go forth and see if you've got all the answers correct. Okay, so let's just click on end exam. You can type your name here. Now let the test run, and hopefully we've got everything correct. So there you go, 100%. So that's just confirms that we have set all the questions correctly, and that has been calculated, and that's your pass score, and the pass percentage is 74. One good thing about the test is that you can go back and attempt it again and test again in case you got any question wrong here. There should also be hints that you can make use of, which is available after the exam has been ended, and try again and try to get a better score and attempt as many times as it takes. So thank you. I hope that this was useful.